Okay, so let's talk about parallel circuits now. A parallel circuit, by definition, is a circuit that has many paths for current, many paths, as opposed to the series circuit that has only one path. And let me draw that right now. And this time we're going to use the symbol for AC, which is a sine wave, as our power source, and a simple parallel circuit here with multiple paths. We'll draw a load there, a load here, and we'll just draw a load there. Now we're going to use the same terminology that we used for a series circuit, which is the total voltage, the total resistance, and the total amperage. So let's start by talking about the total resistance. And what's unique about a parallel circuit is that if all the loads are the same resistance value, then you could use a very simple formula to determine the total resistance. And this only works when the resistors are the same value. So in this example, we'll use 30 ohms as each resistance value. So if that was the case, to determine the total resistance, we could use the value of the resistors that are the same over however many there are. So in this example, the value of them is 30 ohms, and there are 3. And we just simply divide that to determine the total resistance value, which is 10 ohms. In terms of voltage, total voltage, the voltage is going to be the same as the source voltage. So the voltage across these loads here is going to be the same as the voltage source. In this case, let's just say that we were using 24 volts. Therefore, the voltage across each of these loads is going to be 24 volts. And we express that by saying that the total voltage equals the voltage across resistor 1, and that's going to equal the total voltage across resistor 2, and so forth. And by the way, this is how electricians wire lights or wire receptacles. It's wired in parallel, not in series. Although they look to be in series, they're really wired in parallel. So that's important to understand. Next, let's talk about amperage, or the total amperage. And in this case, the amperage is going to be equal to the amperage flowing in branch 1 plus the amperage flowing in branch 2 plus the voltage flowing in branch 3. And what that means is that when the total amperage leaves the circuit here, some of it will be divided along this path and some of it will be divided along this path. So this total here equals the sum of these two currents. And then whatever remains here will go this way, and a little of it will go down this branch, depending on the size of these resistors, or depending on the size of these loads. And when they come to this point here, they're going to add. And the total current at this node here will be the addition of this current plus this current. And the same goes for this node. It'll be the addition of this current plus this current. And then eventually they'll add all up to get the total amperage, which would be here. So the total amperage leaving the circuit or going through the circuit will be the same as the total amperage coming back. And Ohm's law, again, applies to parallel circuits the same as they apply to series circuits. So E equals I, R, which states that voltage is equal to amperage times resistance. And the power rule will also apply. Power, or watts, will be equal to amps times voltage. So you could use these circles in the same exact way that we used them to describe the series circuits. This is E, I, R, and this is P, I, E. Which states that the power is equal to amps times volts, and here the voltage is equal to amps times resistance. So let's solve some problems in the next presentation to see if we could apply these rules and apply these formulas.